We'll deal more now with some cycloalkanes. So if we were to have a cycloalkane, we always still name based off of the largest carbon chain. In this case, it's the cyclic ring itself. So we know that our common chain name here is going to be cyclohexane, because there's 1, 2, 3, 4, 5, 6 carbons involved in the structure. Now the next thing is to name the substituents, and we see that what's left over are these single carbon methyls. What we're trying to do as well is, and it's the case in all namings, we're trying to reduce the number associated with everything. So if we started with a number 1 here, this would be a 2, the substituent here would be a 3 and a 4. So we'd have a 1, 3, 4 trimethyl cyclohexane. But if we did it the other way and had a 1, 2, 3, 4, we'd have a 1, 2, 4 trimethyl cyclohexane, and that would be the preferred way to go. So we want a 1, 2, 4 trimethyl cyclohexane. We can get to some substituents that are much more complicated as well. For example, this molecule. The largest carbon chain, again, is still the cyclohexyl group here, so we know that the base chain name for this is still going to be a cyclohexane. And we now look at the substituents. We have one that's rather simple, but this one here is much more complicated. And how to address that is we're going to see the part that ends up attaching to the carbon of the cyclohexane ring. So this section here, and this carbon right here is going to become the number 1 carbon for this new substituent. So what do I mean by that? Well, if I were to redraw just that substituent itself and wanted to name this, the number of carbons involved in it is 1, 2, 3, so it's a propane. And on the 1 position and the 2 position are methyl groups, so it's a 1, 2 dimethyl. I just ran out of room. Propane. But now that this is going to be a substituent on the cyclohexane ring, we actually don't use propane in the end. We're going to use propyl, YL. So overall, the molecule we're going to have, in terms of alphabetical order, we've got the propyl here and the methyl here. We can call it a 1-methyl, and the 1, 2, 3 position is, and then in brackets, this entire thing is attached. So this is the 1, 2 dimethyl propyl. And so you notice how we said the methyl here with the YL, this is the propyl with the YL, and then finally cyclohexane. Again, running out of room. And we'll try another one where we have an alkyl chain the same length as the cyclic alkyl carbon. If we look at this molecule, we have a straight chain carbon that's got 5 in it, which is a pentane. We also have the cyclopentane. The cyclopentane is going to become the base chain name. It's a little more complicated, so it's easier to use that for the base chain name overall. So then in the positions we have, in the 1 position here, an isopropyl group, and in the 2 position we have the 5 carbon chain, which is a pentyl group. So we can call this a 1 isopropyl, 2 pentyl, or N-pentyl, to denote that it's a linear chain, and that's a cyclopentane. And one last example is where the cyclo chain is actually the smaller one, so it becomes part of the side group naming. So in this case we have a 1, 2, 3, 4, 5, 6, 7, 8 carbon chain. And in the 1, 2, 3, 4 position we have a cyclopentyl group. So it's a 4 cyclopentyl So it's 4-cyclopropyl octane.